Since we're starting the section on trigonometric integrals, it's going to be very important that we can actually do or use trigonometric identities. And the easiest way of doing that is to understand Euler's formula. That's because all the important trig identities are built into Euler's formula. So this is Euler's formula. It says e to the power I times x, where I is the imaginary unit, is equal to cosine x plus I times sine x. So I don't expect you to know a bunch of information about complex analysis. The only thing I expect you to know is that I times I, aka I squared, is equal to -1. There are a few more things we need to understand about this formula. Eventually what we want to do is derive formulas for cosine of x and sine of x that are in terms of exponentials, because it's a lot easier to work with exponentials than it is the trig functions. So we need to understand that this x could actually be anything. For example, if I had 2x here, then I would just have cosine of 2x plus I times sine of 2x. Or if I had 3x instead of 2x, it would change the same way. And deriving our formulas, we're actually going to want to have a negative x instead of 3x. So if we had e to the negative ix, that would give cosine of negative x plus I times sine of negative x. This expression we can simplify. We just need to remember that cosine is an even function and sine is an odd function. A even function is one where if you plug in negative x, you get the same thing as if you had plugged in positive x. So this term simplifies to just cosine of x. And sine is an odd function. An odd function is one where if you plug in negative x, you get the same thing as if you had negative of that function evaluated at x. So we can just pull that negative out in front of that term. These are the two formulas that we're going to use to derive formulas for cosine of x and sine x. The way we do that is actually purely algebraically. We are going to start by adding the two equations together. When I say adding the equations, I mean adding their left-hand sides and their right-hand sides. So if we add the left-hand sides together, then we're going to get e to the ix plus e to the negative ix. And if we add the right-hand sides together, then, well, cosine plus cosine gives 2 times cosine. And I sine x plus negative I sine x, they're equal and opposite, so they just add to 0. They cancel. Now we just isolate cosine of x by dividing both sides by 2. So here's our formula for cosine of x. It's e to the ix plus e to the negative ix divided by 2. We're going to derive the equation for sine of x in pretty much the same way. But instead of adding together these two equations, we're going to subtract them. We're going to take equation 1, subtract equation 2 from it. That'll get rid of the cosines, and it's going to leave me with 2 times I sine x. So going through the details, subtracting the left-hand side, where you get the following: e to the ix minus e to the negative ix. When we subtract the right-hand sides, the cosines cancel. Since I'm subtracting equation 2, this minus turns into a plus, and so I have 2 times I sine x on the right-hand side. Last, we just divide both sides by 2i. Sine of x is therefore equal to e to the ix minus e to the negative ix divided by 2i. These equations are going to allow us to figure out basically any important trig identity very easily, just using our knowledge of algebra and the properties of exponents. In the next video, we'll see an example where we actually derive a trig identity in a particular situation.